Yeah, hello friend. Welcome back to my channel. So today we'll be reviewing the AWS architecture for the listed application Confluence, CloudStack, BitBucket, AWX, CloudStack Cache for Redis, CloudStack NoSQL DB, Couchbase, Data Stack, Enterprise, and MongoDB. Okay. So first understand what is a cloud Confluence. So Confluence is the team collaboration software that changes how modern team works. Confluence Data Center is a self-managed solution that's give you high availability performance at a scale and disaster recovery for uninterrupted access to Confluence for all your team. So we'll review like how to design this diagram on Lucid chart or yourself. So the first of all you need to okay. So this is your account, AWS account. That is the first time you go and create at aws.amazon.com. Okay. Then you create your VPC on a availability zone 1. Okay. Then then you create another VPC on availability zone 2. So what does that mean? It means so you will have a region. Inside that region, you have an availability zone 1 and availability zone 2. So these are the separate data center in a region. Okay. So reason is what? Reason is some specified locations. Okay. And inside that you have availability zone 1 and 2. Okay. So there could be so many regions. Those are specified geographical regions. Okay. Let's say East Coast, West Coast, and inside those areas there are availability zones. Okay. So the objective is if one of the zone goes down, other zones remain up. Okay. Now, once you do this in this VPC, which is in availability zone 1, you have your net gateway and a bastion host. Okay. So what is a bastion host? This is something is important, so you need to know. So this host, what it does, it will give access to the private IP inside a VPC from an external network. So private IP are the IP which are internal to your infra, and it is meant for internal communications. Okay, cutting uh, cutting it an external access, but sometimes you require that your private IP be accessed over the external network or the internet. You need to put a bastion host, and these hosts are configured in a way that it do not allow, or it's restricted. So basically it's restricted, it do not allow much of the traffics to come in, and it is customized. So there is a way, and these hosts which falls under certain rules, the objective is to prevent an attack over the private IP. Okay. So NAT gateway. So NAT is network access translation gateway. So what it is happens. So see, by default whenever you create a VPC you have a private IP. In order for to make your private IP to interact with an external network, you need to use a NAT gateway. That what it does, it actually give you access over the internet, and then once you set up a NAT gateway with the private IP, that is called a public subnet. Okay, which is here. Now this is called a CIDR. Okay. So there will be /20 /26 /27. In other video I'll explain you CDR. This is like a bit of a long topic. Okay? This is called IPCDR. Okay. Same here. You have your database in this private subnet in this 19 CIDR and Amazon RDS PostgreSQL. So relational database system and PostgreSQL. Okay. This is your database. And then you have a auto scaling group. Okay. 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 So same way on your availability zone 2, you create your net gateway, you create your bastion host, and then you put it in a public subnet. Okay. And then in your private subnet, you have another Amazon RDS SQL. Okay. And in this whole VPC, you have an Amazon EFS, which is Elastic File System. So it is a file system provided by Amazon. Okay. This is the internet gateway. From here, your access to the internet happens, and this is your elastic load balancing. Okay, so the thing is like whatever the request comes in from here, it can go to either of this or it can go either of this. Okay, so this is like a basic level of Confluence data center architectural diagrams, and you need to also define route tables and all, which is not part here. Okay, so this is okay. Now let's move to next. So what is a cloud stack fire camp? So the fire camp is to create, manage, and scale stateful service. So you need to know what is the stateful service, okay? Such as Redis, Cassandra, MongoDB, Kafka, PostgreSQL, each. Okay. So this is a DB. This is a DB. This is for Kafka is your for. Okay, I'll explain the Kafka. So what actually happens? Kafka comes in a between of a request and a response. So for an example, that I'm getting a request in terms of a queue. Okay, so Kafka can work as a queue management where it will not let your request to get lost, and centrally you can manage it before it is being sent to backend for this thing. Okay, then you have Elasticsearch for analytic purpose, then you have a PostgreSQL database. Stateful services are those where your Uh, you have to know, I'm not able to exactly tell you the definition for it, but stateful and stateless. Okay, these are the two important. So, stateful, the transactions remain on the server where it is executed. Stateless is the transactions data are onto this thing. So, you can actually look for an example. Okay, now let's see how this was designed. So, this is your AWS account that got created. Okay, now, second thing, what you do after this is you create your VPC in availability zone 1, you create a VPC in availability zone 2, you create your VPC in availability zone 3. So the thing is like first you create a VPC in availability zone 1 and you work on it, then you go to 2, then you go 3, and then you interconnect this. Okay. Now, okay. So this availability zone 1, which is here, okay, this is here, okay. Inside this, you have a public subnet of CDI 20. You have a net gateway for connecting to external network, and then you have a bastion host. Okay, so basically you can also see that bastion host provides access to an IP address if it is not a web-based URL over the external network by securing. So it's like a front-end layer. Okay, then you have, okay, now you have a cloud stack. Okay, so CloudStax is a Firecamp is a product from a third party, and this is installed on an EC2, and where you have a ECS container. So the your root volume is in ECS. Okay, it's not a root based, but it's a container based your root volume. Okay, now here once you do this, you go to you and go and create your availability zone 2. So you here you get your bastion host. Here you get a NAT gateway. Then its public subnet is in 022. This is in a different 144. This is 122, and then you have your ECS container instances, and then it's in a private subnet. Okay, same here. This is another private subnet, ECS container. You have a net gateway. Now you have an auto balancing group. Okay, so the thing is that whatever the access comes here, okay, will be routed on this part. Let me. Okay, so whatever the access, let me see how can I erase. Okay, let's remove this. Okay, let's make it bit clean. And then let's go back here. Okay, So whatever the access comes here, okay, uh, it will go from either this or this. Okay. Now you have your elastic volume system EVS, then you have your DynamoDB, you have a route 53 for resolving your domain name service, and then you have a CloudWatch for monitoring. Okay. Moving to next, which is called BitBucket Data Center. So what the BitBucket does, it is like BitBucket gives professional teams of any size across any distance full control of their source code. Use this example, okay? So basically, this is an example for designing a BitBucket. So when you say that you have a professional team of any size across any distance, full control on a source. So there will be a read and there will be a write. So basically, read would be more, write would be less comparison. Because read is like you will be reading the source code back on your local, doing the work, and then uploading it, which is right. But you will not be writing simultaneously, right? You write once after you make all your changes. So how it goes? So first of all, you get your AWS account. Inside this, you create your VPC. Okay, this is your virtual VPC. Okay, this is your VPC. Now inside this VPC, you create two zones. One is availability zone 1, one is on availability zone 2. Okay. Inside this availability zone, you have your net gateway, you have your bastion host, you have an auto scaling group. So the auto scaling group, the purpose is that if you there are two purposes. The first is like to minimize your cost. So what happens like if you configure an auto scaling group for your architecture and give a parameter, give a your threshold when it has to auto scale or basically define its properties, then it will only add additional resources horizontally, basically like you like your service will run on one on the front app server. If you see the load is increasing, it will add the another app server, and this is the way auto scaling group works. Okay. Then you have a bastion host. You are on a 128.0.24 CDI, and here you are on this. Okay. You have an NFS server, and you're using your database as PostgreSQL. This is a standby, so it means that most of the requests are coming here, and this is getting replicated. And then here Bitbucket utility is here, software which you are installing on EC2, and that is getting auto scaled. And you're using an Amazon Elastic Cache service to do your analytical service. Okay. Let's come to AWX. So AWX is an open source community project that provides software for managing Ansible projects. AWX is hosted on GitHub and provides a web-based user interface, REST API, and task engine for Ansible. See, Ansible is used most for an automation purpose. This is a programming language. GitHub is your source code repository, and this is an open source community that provides software for managing. So it provides some utility to manage Ansible, and it is a web-based user interface with a REST API. Okay. So what you do first, you create your AWS account. In that, you create your VPC here. See the dark line, and inside that dark line, so inside one VPC, you have a two availability zone, one and a two. Okay. You have your net gateway for an external traffic here and here. Your request comes here application load balancings. Okay. Then you have a EC2 container based, so your root volume is on a ECS container, and then you have an auto scaling group. So if the request could not be filled here, it will auto scale, and then you're using a PostgreSQL database. Okay, so, and these are on a private subnet. This is a private, and this is your virtual. So the point is this is the high level diagram. So it does not go that simple as it looks here. So at least if you have this, then you can establish the connections, you can check it out. Then in this utility, you can just try to break down or scale it up, and then see whether the request comes here or not. Okay. This is your RDS. This is Amazon ECS, which is like a file system, and then it's for domain name solution. So you need to have these services in place, and then based on your requirement, you need to put the things here and work on it. Okay. Now go to the cloud stack. So cloud stack catches for you to set up, manage, and scale Redis on AWS. It provides a high performance, scalable, and cost effective in memory database or cache solution that you can use to improve the performance of your application. Deploying a cloud cache on AWS enhances the reliability. So basically, what this is some external programs or software which you deploy in AWS helps you to work better on AWS Redis, which is a product from AWS. Okay. So how you do it? First of all, you get your AWS account here. Then you create a VPC. So if you see here in this VPC, everything is there. So you just have a one VPC, and then you create your availability zone one, and in that you put a net gateway for external communication. You put your Bastion host. You're using a 128.0.20 CDIR, and then you're putting the Bastion auto scaling group, which is here. Then you have a net gateway. Then you have ECS EC2 here, and then you have a Redis Mario and Redis replicate. Okay, same here. So you have a primary, then you have a replication, primary replication, and then also at this level you have an auto scaling group. Okay, then you have a NAT gateway, and you are going in a private sub. So basically, what happened? Your main part is here. Okay, availability zone one, all the request. So the request first goes here, then it auto scales, then it goes here. In case if both goes down, this is the one where you can build or replicate. So basically this will be your on time, a copy of whatever it is running here in time. So you need an Amazon ECS, which is a file system. Amazon EBS is Elastic Volume System. DynamoDB is your database. S3 is a domain name service. CloudWatch is for monitoring the whole AWS infra. Okay. So this is CloudStack NoSQL DB. Okay. So this the how to automatically deploy CloudStack NoSQL DB for Apache Cassandra in a highly available architecture of AWS using Amazon Elastic Container Service for container orchestration. So see, what is the orchestration? So I don't know the exact definition, but if you speak about the orchestration, it means that there is an automated process which take care of the resources behind it. It's like an orchestra or sort of a manager. Okay. And it is giving a stateful service management. So first of all, you create your AWS account and then you create your VPC. That is one. And then you have an internet. Okay. Then you have availability zone one here. Then availability zone two. So basically, first you create availability zone one. Then you put your NAT gateway. Basically you have a public subnet IP is this. Whatever service is running on this IP can be accessed from an external network by this. It will go like this and it will go like this. Okay. And then you have a Cassandra here, and which is hosted on a EC2 container. Root volume is on a container, and this is also auto scaled. Then you have an availability zone here, and you have a virtual private cloud IPs 10.0.16. Then this, and then it's auto scaling, and then you have another one as a replica in Amazon S3. So you need a CloudWatch, you need a for name resolution, you need a DynamoDB, you need Amazon ECS and Amazon EBS volume. Okay. So now go to Couchbase. Okay. So Couchbase platforms and deploy this program to your okay. So what is the Couchbase? Couchbase is a document-based database. Okay. So you need your AWS here. You need your VPC created. Then you have an availability zone one. Here, what you do, you have a NAT gateway for external connections. Then you have a Couchbase sync gateway. Then you have a Couchbase auto scaling group, Couchbase sync gateway. I'll explain. Then it is a load balancing and then internet. Couchbase server, Couchbase server. See what is happening here. You need to understand first. So the thing is like Couchbase is a software. Okay. This diagram says that how do you deploy the services on AWS. So this is not about that you're going to write about the coach base, how it works, it's basically gives you a flexibility that whatever the package you have there, you installed here, okay, and then you install there. So this is an architecture from the coach base which will come, okay. So the thing is like whatever the request comes here, let me remove this, okay. Okay, so what it means that yeah so what it means like that whatever the request comes here before it is served to an external internet gateway, it has to go in the gateway services. So this is internal to the core space architecture, and then it will be processed and sent back from here. And it also have an auto scaling group. So for example, if the request goes from here and there are so many requests has come, and it's this particular server, gateway server. So basically gateway server are the one which will do some encryption, decryptions, and handle certain requests before it is sent to the coachbase server for processing. So there is a two level of auto scaling in this way. Okay, so you design like this. So what now comes to data stacks. Okay, so what is a data stack? So data stacks is a data management software. Okay, it's a third party tool. So how you do it, you create your AWS account, then you create your VPC, then you go to the you create your availability zone 1, you create your net gateway, and you create the DSC operation center. And basically you're allowing whatever the service is running on this CDI 128.0.20 to make a connection outside. Then you have a DSC node, a private subnet. So in this and this, you have your services running. Okay, think like this. And then in availability zone 2, you have a net gateway. You do not have a DSC op center, and then this is running. Okay, private subnet. So basically, you are in the at the AWS level, you're providing the redundancy. Now the question comes like, how do you design these things? So the thing is like, first of all, if it is a new setup, you decide how the services would be run. That is the rule number one based on your technical skills, and you do all the analysis. So if you can refer to my EC2 document review videos before, you will get to know how you decide what to choose and what not to choose. But for this thing, they will have an existing architecture, internally how they are doing. Then you need to customize based on that architecture. So basically you have to maintain the way it is there, and you can suggest how can you get their cost reduced by maintaining the same streamline. For example, if in order for transactions to complete, it has to go from A to B to C to D to E and then F. You cannot have an option that you go from A to E and then F, because you still need to have a provision for, because you're not supposed to change the functionality. Okay, that is the part number one. So you have to work on the same thing. Okay, this I'm giving an example, and this is for file storage. Okay, now let's move to next. So what is a MongoDB? So the MongoDB is the database. So this diagram describes how you set up a flexible, scalable AWS environment for MongoDB and launches MongoDB into configuration of your choice. MongoDB is an open source NoSQL database that provides support for JSON style document oriented storage. Its flexible data model enables you to store data of any structure, and it provides full index support, shredding, and replication. Okay, so index support, shredding, just try to clear it. So basically, shredding is that you are distributing your data, okay, across a different DB instances. It's not partitioning, so that the request gets routed. Okay, so basically it's about threading the whole chunk into small pieces. And replication is like you're keeping a copy of your data from one location to another. So how you create your AWS, okay, account, you sign up for AWS, you have your VPC created, then you are creating availability zone 1, then availability zone 2, and availability zone 3. You have your net gateway and the bastion host on the CDI 128.0.20. You also have an auto scaling group. You have a bastion host and a net gateway, and it's a public subnet 144.0.22. Then you have a MongoDB primary, which is on a private subnet, not accessible from the outside. And then you have another instance, secondary 0 on 032, and you have a secondary 1 on 064. So you can use this baseline to at least create it, and then also this is just the baseline. Okay, so based on that, at least you can set up one scalable, and then you can decide how you're going to work between these two. Okay, and vice versa. So you can just design how, once you're able to set up a communication between a different MongoDB instances in a different availability zone in a VPC in your own AWS console, you can decide how these three databases works with each other. Okay, so thanks friend. Today we went through like 10 AWS, a basic architecture to start with: Confluence, CloudStack, BitBucket, AWS, AWX, CloudStack Cache, CloudStack NoSQL DB, Couchbase, DataStack Enterprise, and a MongoDB. And we'll see it again with some more diagrams, and we'll try to understand more better. So one time I'll just describe what the symbols are, and so that it can help you or me and anybody who watches up to have this thing. And if you like, you can subscribe to my channel Cloud Station 2020 and press a ring button, and see you again. So thank you.